This week we'll be learning about perfect square roots and estimations. First, we're going to talk about perfect squares. Square numbers are also called perfect squares. A number that is the square of a whole number. It can be represented by arranging objects in a square. Like down here, 1, the square root of 1 is 1. 4, we have 2 rows of 2, so the square root of 4 is 2. 9, we have 3 rows of 3, so 3 times 3 is 9, so the square root of 9 is 3. 16, 4 rows of 4, which 4 times 4 is 16, so the square root of 16 is 4. We can also represent square numbers by a multiplication table. Now in class tomorrow you will have a larger multiplication table that we will work with, but for now we're going to work with this one. We can see our perfect squares all the way down the center. So let's look at 81. 9 times 9 is 81. So the square root of 81 is 9. 64. 8 times 8 is 64. So the square root of 64 is 8. Another way we can write a square number is writing it out. And that means like the number that is a product of some integer with itself. You will calculate the perfect squares up to 25 tomorrow in class. Now, I want you in your journal right now to write down what does it mean by product. Even though it gives you pictures up here, what does it mean by the number that is a product of some integer with itself? Here's some integer, the product of itself equals a number. So the square root of 4 is 2, because 2 times 2 is 4. The square root of 9 is 3, because 3 times 3 is 9, and so on. So tomorrow you will be writing down these numbers, and I only put 1 through 15 on here, but we're going to go ahead and do 1 through 25, so it might be something you want to think about tonight. Okay, next in your journal, I want you to answer this question. Identify the following numbers as perfect squares or not. I want you to write these down, write yes or no next to them. Are they a perfect square or are they not? And we will go over your answer tomorrow. Now we're going to go over square roots. Square numbers. One property of a perfect square is that it can be represented by a square array. Each small square is the array shown has side length of 1 centimeter. So this is 1 centimeter by 1 centimeter. And then the larger square has a side length of 4 centimeters. So we have 1, 2, 3, 4 makes up the larger square. The large square has an area of 4 centimeters times 4 centimeters, which equals 16 centimeters squared. Now this is squared because we multiplied two numbers together to come up with this answer, so therefore it's squared. Now if we look over here, we have 4 times 4 equals the area of 16. So let's say if we didn't know it was 4 on each side, and you only knew the area was 16, all you would have to do is find the square root of 16 to find your side lengths. So the number 4 is called the square root of 16, and this is how we write it. A number which, when multiplied by itself, results in another number. So we're talking about 5 is multiplied to itself, which would be 5. That result in another number, which is 25. So the square root of 25 is 5. Now let's go over what all the parts of a square root mean. The index is your number that goes on the outside. Now that is not anything you will be dealing with this year. You will learn more in Algebra 1, Geometry, and Algebra 2. But just for your information, next year you should know it's called the index. Then we have the oversized check mark. That is called your radical. Then the number that goes inside the radical is your radicand. Now let's look at another way to find a square root. This is another way. We can use the following strategy to find a square root of a large number. Now I'm going to use 36 now because it's not quite that big, so we'll start small. So if we take 36 and we factor it, which is 4 times 9, because 4 times 9 equals 36. We separate them in their own square roots. We find the square root of those two. So the square root of 4 is 2 times square root of 3 is 9. The square root of 9 is 3. And then you do 2 times 3, which is 6. Well, the square root of 36 is 6. And here we have it again. We can factor large perfect squares into smaller perfect squares to simplify. We simplified it by 4 times 9, and then we found the square root of those two, multiplied them together, and got 6. Okay, now what I want you to do in your journal, take 256, factor it, find the square root of the two numbers you factored, multiply them together, and get an answer. So if we look at this one, I laid it out for you, so all you have to do is fill in the blanks. So write that in your journal. We'll go over your answer tomorrow. Now let's talk about estimating square roots. We have 25. What is the square root of 25? Write that in your journal. The square root of 25 is. Now, if you said 5, you are correct. What is the square root of 49? Write that in your journal. The square root of 49 is. If you said 7, you are correct. What is the square root of 27? Can't find one, can you? That's why we have to estimate. There is not a number multiplied to itself that make up 27. So when you have numbers like this, we need to estimate. That is what we call irrational numbers. Since 27 is not a perfect square, we have to use another method to calculate its square root. So, not all numbers are perfect squares. Not every number has an integer for a square root. So we have to estimate square roots for numbers between perfect squares. So we need to find the square root that goes before 27, and we need to find the square root the perfect square that goes after 27. Okay, so to do this, we are going to take those perfect squares, the one that is adjacent to the number 27, and we're going to place them on a number line. And then we're going to interpolate between the points to estimate to the nearest tenth. So therefore, we're going to take a number line, we're going to place 25 and 27. We're going to count the proper tick marks in between to be able to find the estimation of the square root of 27. So here we have our number line. 25 is adjacent. It's right before 27. It is the closest perfect square next to 27. Then we have 36, which is the closest perfect square adjacent to 27. Place them on a number line. So we have 25, and then we have 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. And if you don't have to write every number. If it makes you feel better to write it out, you may, but if you want to write it just like this is just fine. So we have our numbers, place our perfect square. Now we place our 27. Since that's 25, we go 26, 27, and then we put 27 right there, since that is the number that we're working with. Then you need to find the square root of 25 and the square root of 36. So 5 is the square root of 25, and 6 is the square root of 36. So 27, the estimated square root of 27 is going to fall in between these two numbers. Okay? So now we look. The estimated square root of 27 is 5.2. How do we know it's 5.2? Well, if you look at 5, 2 tick marks after 5. So it's 5.12. That is the closest that we will get to estimating the square root of 27. Now let's check and see if it works. 5.2 times 5.2 equals 27.04. That is the closest that we will get to a perfect square. You will not get a perfect square for 27. And we only go to tenths, hundredths afterwards, because if we go further than that, it's too large of a number. But just for estimating square root of 27, 27.04, 5.2 times 5.2, that is close enough.